Let me record the. All right, so can you see my screen? Okay, with all the files in this sharing folder. So if you look at the first one over here, so in fact it says 2021 S1. So it represents the year 2021. S1 means secondary one. HW0 means homework 0. So you can see that homework 1 next, and then of course you see homework 1, and then JX is your work, and of course homework 1A, so it's additional homework for homework 1, and of course homework 2, homework 3, homework 4, and then 4A, 4B, 4C. So this is how these files are actually arranged. Okay, so you have completed JX HW2 intro. So I put your name in short form, so that I know this is your completed work. Okay, it's from you, not from Yuxing. Okay, so this is yours. So that means the next assignment you are supposed to do is homework 3. All right, homework 3. Are you clear?
Yes.
And then of course, if you want to go ahead and do more because you have more time, then homework 4 will be the one next. And if you still find that, oh, you have a lot more time, then of course you can take a look at homework 4A and then 4B, 4C. So a lot of practice for you. Okay. And before we start, like I say, I have shared a PDF with your mom, which you can take notes with the app notes here. Okay, this is the one. All right, is on your iPad. Just want to brief you about how you can take notes. Okay, so in fact this is the one I would like to show you. Okay, so in fact this is a summary of what you need to do or what you need to learn in chapter 1 of set 1. This is not set 2, by the way. So let me edit it. So it should be set 1. And then of course once you read, okay, there are a lot of words here, right? So in fact you can also actually link a video to this summary. So you just need to press this, and then you will be directed to the a YouTube video. All right. So if you have your iPad, right, you can actually do a split screen. All right, you can do a split screen so that you can see this file and the YouTube video side by side, something like this. So this is your file on the left, and then this is the YouTube video on the right. So that's how you can actually split screen on your iPad. All right, and then of course you can insert pictures, and then of course, yeah, so on and so forth. All right, so you can actually take this as an example, and then you improve on it. All right, understand?
Yes.
Yeah, I don't know how you students take notes this day, but if you have an iPad, I think it's very, very convenient, especially if you know how to use the notes app over here. You can add link, video link, and you can add picture, and then of course you can write with your Apple Pencil, so you can actually use this app. Okay, so you don't have to use papers anymore. All right, so make full use of this. Okay, so let's jump to your work. So I will refer to these notes later on because we need it. All right, so over here, you start here. So you start negative numbers, integer, rational numbers, and all this. What do you mean by starring this? Why do we need to learn about negative numbers? You star it. Why you star it? Can I ask?
I don't know how to.
Okay, you don't know how to put your idea into words, probably. Okay, so let me just make this bigger. Okay, so over here, right? So in fact, all this negative number, integer, rational number, real numbers, in fact, I have already summarized them in this picture already over here. Can you see this picture here under real numbers? Can you see it?
Yes.
Yeah, okay, good. So let's take a good look at this this summary over here. So in fact, in this mathematics universe, okay, so in fact, for your level, you just need to know real numbers. Okay, there are unreal numbers which you don't have to care about at this stage. All right, They are called imaginary numbers, which you don't have to care about at your stage. So real numbers are numbers that you need to learn at your level. And next, under real numbers, you split to rational numbers here and irrational numbers here. All right. So for irrational numbers, here are some examples of irrational numbers. Okay. So like pi is an irrational number because it's indefinite. It's 3.1415 blah 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 non-stop. Okay. That's why you need to, you need to learn irrational numbers so that you know how to represent them. Okay. And of course, if you come to the left side here, rational numbers. So these are rational numbers. So before we go into the integer circle, out of the integer circle, you have fraction. Can you see 24/4? Can you see this fraction? And then can you see that there is a decimal number here, 4.5? And then you also have the negative 6/7, which is a negative fraction. They are called rational numbers. All right. And then of course, you have this 0.3, and then there is a slash above. So 0.3 slash on above. Do you know what's the meaning of this? If you don't, I'm going to explain to you. All right, so there is this funny 0.3, and then there is something above. Or actually, you could have written it this way as well, like put a dot above. Do you know the meaning of this? Either of this?
I don't know.
Okay, so the meaning of this is, in fact, what if you have 1/3? Okay, so the fraction 1/3, if you try to find the decimal number of 1/3, right, you are going to have what? 0.3, and then you have 3, you know, all the way. Okay, so you have 3 all the way, and it never stops. So there is a better way to represent this 0.33333 non-stop. So you can either use this way to represent it with a dot above, or you can use it, or you can use this way to represent 0.333 non-stop. All right. So this 0.3 with a dot above means 0.3, and then the number 3 here. Okay, because you dot this number, so this number actually repeat itself non-stop. That's the meaning of it. Okay. Similarly, if you have a small minus sign above, okay, above the number 3, so you are going to have 0.333 non-stop. That's the meaning of it. Okay, so I'm going to give you another example. So, okay, sorry. Okay, I should just, okay, what if you have 0.12? So you have a dot above 1, and then you also have a dot above 2. So what do you think is the meaning of this 0.12 with 2 dots above? What do you think? What do you think is the answer for this?
1, 2, 1, 2, 1, 2.
Exactly. Okay, so that's the meaning of this. So you are going to have 0 point, because like I said just now, if you have dots above the number, it's going to repeat itself non-stop. So 1 is going to repeat itself, and then 2 is going to repeat itself. So you have 1, 2, 1, 2, 1, 2 non-stop. That's the meaning of this 0.12 with 2 dots above. All right, so this is a much better way to represent non-stop numbers. Okay, so this is considered rational numbers. All right, so the difference between this, let me duplicate this. So the difference between this 0.12 with 2 dots above versus 0.1234 all the way. All right, so this is the irrational number. All right, irrational number. Okay, why? Because first thing is non-stop, and then there is no pattern. Okay, so non-stop plus no, there is no pattern. Okay, there is no pattern in the numbers. All right, but over here you can see that it's considered rational number. Okay, why? Even though it's non-stop, but there is a pattern. Okay, there is a pattern. The pattern over here is 1 2 1 2 1 2, and then the 1 and 2 they repeat itself. All right, so that's how you decide. All right, so are you clear?
Yes.
Good. So let's come back to this picture. So we have talked about rational numbers. So let's go to the integers universe, the circle. Okay, the I would say the slightly less blue part or gray part. So for integers, you have what? So if I use the PowerPoint to illustrate to you. So for integers, so remember for integers you have positive integer, and then you have 0, and then you have negative integer. All right. So for integer, you can split to these 3. All right, and then for positive integer, they are also called whole number. All right, so in fact, I have already summarized all these into this already over here. Okay, over here. Okay, so that's why I say this is a very good summary PDF for chapter 1. All right, so if you find that words are a bit hard to understand, then of course you can have a picture over here. All right, can we move on back to your this homework? All right, so let's come back with your homework. Okay, so why do we need to learn about negative numbers? Because if you just learn positive numbers, then you don't know how to there are many scenarios in life we need to use negative numbers. Like let's say if I lost $2. So how do you represent the statement I lost $2? So if you have learned about negative numbers, so you could have written -2 to represent this statement. All right, I lost $2. All right, so what is the significance of negative numbers in real life? Yep, so I just demonstrated to you. Okay, you can actually use a mathematics representation -2 to represent this simple statement. All right, okay, Ken?
Yes.
So if you read some of the financial statements, right, for some companies, so if you're talking about Tesla, let's say you're talking about Tesla, right? So if you read their financial statement, their profit can be, the number can be -2 million. So what this means? This means they are not making any money for the past quarter. They are losing -2 million. That means they are losing $2 million last quarter. Okay, so this is how negative numbers can be used in real life. All right, so far so good. All right, okay, good. Now then, why do rational numbers exist? Okay, we just talked about what are rational numbers. Oh, they are all here. Okay, so rational numbers, okay, it has what? For rational numbers, so you can split to fractions. Okay, and then you can also split to integers, and of course you can also split to things like this, decimal number 4.5. Okay, so rational numbers, they are there for you to represent different things in life. Okay, for example, you have you have eaten 1/8 of a pizza. Okay, so you have 1/8 for you to represent that statement. All right, so rational numbers, so basically you have more numbers. Okay, that means your knowledge base about numbers has broadened so much after learning rational numbers and irrational numbers. All right, are you still there?
Yes.
All right, okay, good. So now so if you have learned about rational numbers, right, then you will start to see that all these, they start to make sense. Okay, all these questions, they start to make sense. All right, so let's continue. So okay, how do you do this question? So first thing first, do you know what's the meaning of this? We talked about it. This is a square root sign, right? Am I right?
Yes.
So if this is a square root sign, so you have 4 squared. So 4 squared is 16. Then plus 6 squared is 36. So you're going to end up with square root 52. So square root 52 is the answer. Okay, and square root 52, it falls under the irrational number region, right? Am I right? Are you clear?
Yes.
Let me get this into the PowerPoint, so it's easier for me to have more space to work with. All right, good. So let me just duplicate this. Okay, good. So let me just cut this. Copy, paste. All right. Okay, so if you have learned about the concepts of rational numbers and irrational numbers, then you can actually write down the answer for each of this. So basically, this is square root 52. We did it just now. So the answer stops here because this is an irrational number. All right. So last time, let's say before you learn about irrational numbers, probably you have square root 52, and then you are going to find out what is square root 52 by punching this square root 52 into your calculator, right? So what's the answer if you punch this into your calculator? Square root 52. Actually, I can launch my calculator here. So I press 52 and then I press square root. So you're going to have a 7.21 blah 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 blah. So there is no pattern to it. So 7.1 something 2 da, 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 all the way. Okay. And of course, you don't need to write in this manner anymore because you have learned about irrational number. So the answer is basically square root 52. Okay.
Yes.
Move on. Second one. For the second one, I think you can see that for the second one over here, so you have a square root 16 minus 36, and then you are going to end up with square root negative 20. And did we talk about you cannot square root a negative number? Did we talk about it last week?
Yes.
You can't square root a negative number. Okay, this is something like you cannot divide by a 0. Okay, you cannot divide by 0. Okay, you can't 2 divided by 0. Cannot. Basically, 0 cannot be a denominator. So this is something you will have math error in your calculator. So this is the same thing. So what if you end up with this square root negative 20? So how are you going to answer the question? What if you really face this question in your exam? So you're going to write, you still need to write negative 20 out. I mean square root. So you just write square root negative 20 and then just you say no answer. Or there is another word which is I think is a better word. It's called undefined. Undefined means can't be found. Undefined. Okay. So undefined is also an answer. No answer cannot be found. Also can. It's also an answer. All right. Okay. Okay. Next, this one will be easy. I think you get a answer out of this because you have 16 and then plus 9 and then square root 25. Square root 25 is 5. Okay. So I'm just taking all these 3 examples here, okay, to help you explore the possibilities of answers you can have, okay, like irrational numbers, undefined, and of course this is an integer 5, or you can call this a positive integer, or you can call it a whole number. All right, so I'm just taking these 3 examples to let you have an idea, okay, what kind of answers you are going to get, okay, for secondary 1. So far so good. Okay, let's move on. If you have no question, so over here, this is the kind of question you're going to expect from your exam. Okay, this one. So how do you do this question then? Any idea? Oh, by the way, you have your Apple Pencil. You can actually do it on the screen already. So how do you do this question? Let me give you a big canvas so that you can. Yeah. So how do you do this question? Oh, can I ask you to use red or a bright color, a blue, a dark blue? Because over here my screen is a bit your color is a bit not so clear. You are using light color. And yeah, very good. So next time, right, when you use your Apple Pencil to do on a PDF, right, I suggest you instead of using black color, please use dark blue. So it's different from the questions because the question is in black already. Okay, so good. So do you think you need to continue to figure out square root 60? Or just stop at square root 60? Yeah, okay, good. So in fact, you are not 100% correct. Okay, I'm going to tell you why. This is a very common mistake when it comes to this kind of question. Okay, yeah. So you only get one answer. In fact, you are supposed to have two answers. I'm going to explain to you why. Okay. Okay. I suggest you to use dark blue later on because I'm going to use red to mark your answers. Okay. So anyway, use dark blue later on. So step 1, correct. Step 2, correct. This is also correct. And this step is partly correct. I'm going to tell you why. Okay, let me duplicate this. So oh, this is your I need to clear clear this. Clear. Okay, good. So let me just make a few more because I'm going to need a lot more. All right. So I was saying a squared equals to 60. Okay. So let's not do a squared equals to 60, which is our question and your answer to the question. So let's do a squared equals to 4 first. Okay. So remember, this is called the power. Okay. And this is called the base. All right. And in fact, this is a to the power of 2. That's how you read it. Okay, you can call it a squared. Okay, or you can read it as a to the power of 2. Okay, either way will work. Okay, so for the power 2 here, okay, so remember, for even power, okay, you are going to have two answers instead of one. Okay, you're going to have two answers. A lot of students, they just take the answer from their calculator because the calculator only give you one answer if you're going to do this. So let me continue. So a squared equals to 4, right? What a lot of students do is they just do a. So like I say, if you have a squared here, what you need to do, you need to square root. Okay, you need to square root it because the opposite of square is square root. So square root is the opposite of square. Okay, so you need to square root to get a in this case. And a lot of students, they missed out the other answer because this is what you are going to get from your calculator. In fact, you need to do this. Okay, so this is only 50% correct. Okay, what you're going to do, you should do this. A squared equals to 4, you should do this. A and then plus minus square root 4. So if you continue, you're going to get 2 or negative 2. And I'm going to I'm going to show you why you are going to get two answers instead of just one, which is wrong or partly correct. So how I do it, I just need to key in the 2. I just need to key in the 2 or key in the -2 back into the question. So 2 square, I ask myself, what's the answer? Square root 2 square, what's the answer? And if you key it into your calculator, can you do it for these two examples? For this example and this example, and see if you can get 4. Are you already doing it? Hello, are you there?
Yes.
Good. So do we get 4 for both of this? Have you finished? Or you need to unmute?
No.
Or not yet? You know how to key these 2 into your calculator?
Yes.
So do you get 4 for both of this? You should be pretty fast, huh?
No.
You don't get 4 for both.
Mm.
So the first one you get,
I get. Wait, let me check.
yeah.
I get 4.
Yeah, 2 to the power 2 should be 4. Then what about the next one?
Math.
Over here, bracket over. By the way, you should put a bracket. Then inside the bracket, put -2, and then to the power of 2. So what answer you get? You're not supposed to get a math error, by the way.
Oh, it's 4.
It's 4, yeah. Okay, so can you see that both give you 4? I mean, both to the power of 2 give you 4. So that's why your A is equal to 2 or A is equal to -2. So you are supposed to have 2 answers instead of just 1. All right. So remember, when you have even power, then you have to have 2 answers. The +1 and then the -1. I'm going to demonstrate to you one more. We have demonstrated A to the power of 2. So what about A to the power of 4? So once again, the power is an even number. Okay. So 4 is an even number. That means the power is an even number. So what if you have A to the power of 4? I think 81. So how do you do this question? Okay. So you have A to the power of 4. So you need a 4 square root to counter the power 4 to get A. So 4 square root, 81. All right. So if you press this into your calculator will only give you what? One answer. But since this power is an even number, you need to have plus minus. Yeah, plus minus. So therefore, you can write it this way, or you write it +3 or -3. Are you clear?
Yes.
So you are supposed to have 2 answers for even power. Okay? Can I? Okay, a lot of students they make this mistake. They got penalized because they generally miss out the -3. All right, because the calculator only give you one answer. All right, so let's move on. So you have a taste of how this square root and negative numbers, they are going to be used, okay? Or how you will be tested, okay? Given questions like this. All right. Okay, so the fractions, the addition and subtraction of fraction, right? In fact, this is just two examples to show you how you can actually use the concept of LCM, common multiple, lowest common multiple, to solve questions. Okay. Oh, I need to insert from the desktop. Hold on. Okay. So have you learned addition of fraction and subtraction of fraction in primary school?
Yes.
Okay, good. So in fact, if you have not realized, okay, in fact, what you have learned in your primary school is, so you have two fractions. So what you need to do next is you are going to make the denominator the same. How do you make the denominator the same? You need to choose the lowest common multiple. But most likely, you were not taught this concept of LCM in primary school. They just ask you, okay, you just do it this way. Or did they talk about the concept of LCM in primary school? For addition of fraction?
No.
No, okay, never mind. So in fact, over here, what you do, you're going to times 7 for the first fraction, and you are going to times 3 for the second fraction. And then, of course, therefore, you make the denominator the same. They are both 21, right? And then, of course, then you add them up. So you get 55 over 21. And of course, this is an improper fraction. You need to use a proper fraction as the answer. So you're going to have 42. So 42, you're going to have 13 above. Okay. So there's nothing for you to learn here. Okay. But I want to point out to you, you are actually using LCM here. The concept of LCM. Okay. Why I say you are using the concept of LCM? Because you could have done it this way as well. So instead of can you times let me see. Can you times 14? So yeah. So this way you are going to get 42 as the denominator. And then of course above you're going to get 98. And then over here you get 12, and then you get 42. And then can you see that the denominator is also the same, right? So if you have the same denominator, you can continue. But it's just more complicated. So you're going to have 110 and then over 42. Of course, you need to simplify. So this is 55, simplify 21, and then yeah, you end up with the same answer. Right? You end up with the same answer. But why didn't you use this? Why didn't you times 14? Over here, why didn't you times 6? Okay, because you don't want to have a bigger common multiple. You want to have the lowest common multiple so that you play with simple fractions, or at least a simpler fractions than this. Okay, I think in your primary school, your teacher did not mention the concept of lowest common multiple to you. They just ask you, okay, you just do it this way, and then yeah, just accept it as it is. In fact, you're actually making use of the lowest common multiple here. Are you clear now?
Yes.
So in fact, a lot of other questions like this, let's say you have a 5, 15, okay, then plus 3, 5 over 3. In fact, for this one, you don't have to do anything to the first fraction, because 15 is the lowest common multiple between 15 and 3. So you just have to do, you times 5 for the second fraction. And you're going to end up with 5 over 15. And of course, this you are going to have 25 over 15. And of course, you have 30 over 15. And then the answer is 2. This is one way. This is one way. Okay. Of course, you could have done it differently. All right. So instead of finding the common multiple, what you could have done here, I think you can see that you can actually simplify this, right? Right? You can divide by 5, top and bottom. Then you end up with 1/3. And if you end up with 1/3, then the entire addition becomes much simpler already. So you're going to have 6/3, and 6/3 is 2. So can you see you get 2 for both answers, but much simpler. Okay. Okay. Over here, you make use of the concept of LCM. Okay, 15 and 15. And over here, you just see that there is a possibility for you to simplify. Okay, then you proceed. So in fact, this method is encouraged. If you see opportunity to simplify, you simplify before you proceed. All right. Okay. So the two questions here, I just want to demonstrate to you. You are actually making use of the concept of LCM, lowest common multiple. Okay, which you might not be aware of. All right. So over here, this question. Yep. We just talked about it just now. How come your answer and my answer is a bit different? Is my answer wrong? Or are we doing the same question? Let me put it side by side. Okay, so this one, let me see, 49, then this is 6. Did you use calculator to do your question? If you use calculator, then I will trust your answer more than I trust my answer already. Okay, so let me see. So this is 49/21. Can you use your calculator once again? I just want to double check whether your answer is wrong or my answer is wrong for this question. 7/3 plus 2/7. Can you help me out? I think you are wrong because it cannot be 14 as the denominator. Over here. I don't think it can be 14 here because 3 and 7. So the lowest common multiple is 21. So the denominator should be 21. That's how I just use I call this the easy and lazy method to check answer. Okay, so most likely you are wrong here. Okay, for this one, I think you aren't correct because this is not the simplest. So you are supposed to write in simplest form. So this is right because this is still an improper fraction. So remember, so this is an improper fraction. You know what's the meaning of improper fraction?
Yes.
So for improper fraction, that means the numerator is bigger than the bigger or equal to the denominator. So that is an improper fraction. So for improper fraction, it's not the simplest form. So you are supposed to write in this manner. All right. Okay. Yeah. So this is the question here. Oh, this is the one I want to talk about. Okay, I look at your answer and then you did not continue. I don't know why. So let's get it out and let me do it on PowerPoint. Okay, so in fact, this is a x squared plus 3x plus 2 equals to 0. So this is a quadratic equation, quadratic equations. Okay, the name for it is quadratic equation. Why? Because the power is 2. So because the power is 2. Okay. So just for you to know, okay, the name for this kind of equation is a quadratic equation. Okay. You don't have to know it by now, but just for your knowledge. And then over here it says A is equal to 1, B equals to 3, C equals to 2. Then you are going to find X using this formula. Have you encountered this formula before? I don't think so, right? Because this looks so complicated. All right. So let's make use of this complicated formula. Okay, can you see that there is a plus and minus sign here, which I introduced to you just now? A squared equals to 4. So A is equal to plus minus square root 4 and then plus minus 2. So in fact, this formula here, you can actually split into the first formula is with the plus sign. Okay. And then the second formula is with the minus sign. So this is the meaning of it. Okay. So far so good. And then the rest, what you do, so you just plug in the numbers. I see your attempt. Okay, you try to plug in the numbers. Okay, so b equals to 3. So I remove my b. I replace it with 3. Okay, and over here 4ac, right? The meaning of 4ac is 4 times a times c. Okay, over here 2a means 2 times a. All right, so a is equal to 1. So I'm going to replace my a with 1. So I just use my eraser. Okay, I replace by 1. And then the c is 2. So I replace my c with 2. Okay, so I do the same thing for the second one. Okay, I'm going to do the same thing. B is 3. I'm going to put 3 in. And A equals to 1. So this is called substitution. Okay, or replacement. So C is 2. So after this, what you need to do, just let the calculator do the job for you. But of course, you can simplify it before you use the calculator, because I think the calculator has too much to digest if you don't simplify it for the calculator. So let's simplify for the calculator first. So where 2 times 1 is 2, 2 times 1 is 2. All right. And then inside here, you have 3 squared, which is 9. So let me simplify it first. And then of course 4 times 1 times 2 is 8. So this is 8. This is also 8. So I just replace it. Okay, in fact 9 minus 8 you get 1. So you can simplify it further. Okay, I'm demonstrating it to you. That's why I do it slowly. So I hope you can keep up with my pace. Okay, if I do it on my own, I'm going to be super fast. Okay, all right, over here square root 1, you can press your calculator. Square root 1 is 1. All right, good. So you have simplified it enough. I think your calculator can handle it now. So you get square root 2 over 2, which is -1, which is one answer. And then you have -4 over 2, and then you're going to have -2. So you have 2 answers. So far so good. Okay, this is how you use this formula here to solve the quadratic equations given. All right. Okay, so let's use your calculator now to solve this question. X squared plus 3x plus 2 equals to 0. Let me double check the question. Yes. So can you use your calculator? Okay. You remember how you go to simultaneous equations using your calculator? So you do it the same way. You go to equation. I think option 3. Option 3 looks like this. Ax squared plus bx plus c equals to 0. Can you try it out using your calculator? And then in this case, your a is 1. So you key in 1, and then you key in plus 3, and then you key in plus 2. And then you press enter, you're going to get 2 answers. Can you test for me using your calculator? I hope you still remember how to use your calculator to go to equations. And then you press 3 for this option. And tell me the answer from your calculator. Are you able to find it? Or you need some help?
No.
No. Okay. So first thing first, do you know how to go to okay, do you know how to go to this option or not? You go to equation. Remember, like last time we have x plus y equals to 2, and then of course x minus y equals to -1. And then you know how to key in the 1, and then key in the 1, and then key in the 2. Do you know how to go to here this step first for simultaneous equation?
Yes.
So I think you key in 2, right? You key in 2 to go to this setting, right? So instead of 2, right, I think you see a third option, which looks like this. Can you see the third option or the fourth, which looks like this? Ax squared plus bx plus c equals to 0. Can you see that?
Yes.
So once you choose 3, right, then they will ask you key in your a. So you key in 1, key in plus 3, key in plus 2, and then yeah, that's it. So you key in 1, 3, 2, then just press enter. Then they will give you the answer for x already. Cannot.
Negative.
Yeah. Negative
1.
1, and then press one more time, equal.
Negative 2.
Correct. So you have -1, -2 from the calculator, and we just did it using the formula. We also get -1 and -2. So I'm just trying to tell you, for quadratic equations, you can use this formula, okay, or you can use your calculator, but you need to know how to use your calculator to choose option 3. So far so good?
Yes.
Okay. So for the first half of the lesson, I think you have learned pretty a lot. Okay, a lot of stuff, right? A lot of new stuff. All right. Let's go back to our homework. Okay, so this one, you stop here. Can I ask why you stop here? Why you never continue? Or did I miss out anything?
I did write negative.
You mean you have a -2 here?
Can you see here?
Okay, I can't see anything over here. But anyway, never mind. So next time, to differentiate your working from the question, right? So please use a dark blue. All right. Okay. I see a -1 here. Yeah. Okay.
Yes.
Next time, just use a dark blue, or one more thing. In fact, right, you use your Apple Pencil. I think you can choose the thickness. So over here, can you see over here? You can actually choose, this is thicker, and this is thicker, and then this is the skinny one. So this is the skin. So if you find that yours is not so I would say not so clear, and then of course you can use the thicker one. All right. So just choose a darker color. I think dark green is quite good as well. Yeah. Okay, this is dark blue. Okay, so up to you. Just choose a color that is easier for us to look at, and it differentiates from the question. All right. All right. Next, it says representation and ordering of numbers on the number line. Okay. So first thing first, you manage to rank. Okay, and you are ranking all this in what manner? From small to big. All right. Oh, so now I realize 22/7 is actually bigger than pi. Let me double check. Don't know about it because I have not verified it. Yeah, let me clear it first. Yes. Okay. So you manage to rank them from small to big, but over here it says represent on a number line. So I'm going to talk about how are you going to do it. But the first thing is your step 1 is correct. The step 1 is very important. You need to know how you rank them from small to big. The next step is make use of the number line here. I'm going to draw another number line because I have messed up here. But anyway, I can actually draw another number line. So this is my number line. Okay, so without doing this question first. So how do you draw a number line? So you locate your 0. Okay, on the left hand side of 0, you have the negative region. On the right hand side of 0, you have the positive region. Okay, what I'm trying to say is you are going to have like positive 1, 2, 3, 4, and then of course it goes on and on. Okay, but I'm going to stop at 4. And then of course for this side you have negative 1, negative 2, negative 3, negative 4, and it goes on and on all the way, negative 100, but I'm going to stop at negative 4. Okay, then now let's look at the question. Okay, you know that negative 3 is the smallest among all these numbers, so you need to locate negative 3. So negative 3 is here. So negative 3 is here. Okay. Okay, in fact, I think you should use a different colors to so-called show your working. So I'm not going to use blue. I'm going to use another color so that it's different from this number line. Choose purple. Of course, you cannot choose purple during your exam. I think during your exam, you can only use blue and black, right? Am I right?
Yeah.
Okay, good. So you're supposed to use blue and black during the exam. Okay. Over here, I can play with more colors. All right. So you have a number negative 3. So you just highlight, mark it on the number line, and then you just label negative 3. What's the next smallest number? Negative 2/3. So where is negative 2/3? Somewhere here. Right? It's in between -1 and 0. So it's negative 2/3. Okay. And then the next is 3/14. Where is 3/14? Somewhere here. You marked it. So you can actually use the arrow 3/14 to help you a bit. Because these three numbers, they are very close to each other. Okay. So for pi is 3/1415 . So it's just right next to it. All right. And this one is 3/14 something. I know it's a bit off, but like I say, because this is your drawing. Okay, this is your drawing or sketch. So we don't expect you to be 100% correct, but it should make sense. What do I mean by that? 3/14, pi, and 22/7. You should label them such that 3/14 is on the left, pi is in between, 22/7 is on the right. So this makes sense. Okay, I know it's not very accurate because it's very hard to make it accurate. Okay, because this is a sketch. All right, and then of course you have 5.5. Oh, so looks like I need to extend this a little bit. So I'm gonna extend it a little bit. So I just extend it a bit. This is 5, and then this is 6. So I'm going to label here 5.5. All right. So you have already represent all these answers on a number line. That's how you represent them on a number line. So are you clear?
Yes.
So if next time you have a few numbers and you are asked to represent them on a number line, this is what you should. This is what you should do. Okay. Let's move on. So this is super simple. This is correct, and then this is correct. Because this 1/3 is actually 0.3, like non-stop. That's why I use a dot above. -2 is bigger than -3. Okay? Do you know why? Why -3 is smaller than -3? Okay. One way to look at it is you can look at it with. Can you see that now -2 is? You know that this is small, right? This is big. Okay, so -2 is bigger than -3 if you look at the number line. Okay, this is one way to verify this. Another way to verify this is, okay, -3 is lose $3. 2 is lose $2. So you just need to ask yourself. So lose 3 is worse than lose 2, right? Lose 2 is better lah. Okay, in a sense. So over here, correct also. Okay. So like I say, hey, by the way, do you know how to key in this or not? How do you key in this in your using your MacBook or your? Do you have a keyboard for your this? How come I have this pop up? Sorry. Okay, let me get it out. Do you know how to key this sign in? This is called the smaller and equal sign in your iPad.
Under comma.
Under comma. Okay, yeah.
On the comma.
Yeah, on top of the comma sign. But that one is a smaller sign, right? That means what I see is you are going to have this above comma. So this is your key, right? By the way, are you using a keyboard or you are using the iPad only, the touch screen only?
Keyboard.
Oh, you have a keyboard with the iPad.
Yes.
Okay, good. So you can actually test how you are going to type in this. How are you going to type in this? Okay. What you can do is you can try using this. I'm not sure if you see this key. This key is called the ALT and then the option key. And you just press this key. You just press this key and then you press just now that key. Then you are going to get this. You see, I have enter this smaller and equal. So basically, you just need to key this. I mean, these two key together. You try, and you are going to get this. Or anything with alternate, the word alternate. These two should give you this. Can you like try to message me over this Zoom and then see if you can key? Can you? 可以吗? Let me also try it. Yeah, I can. No, you cannot. How come you cannot? You must press the alternate and then together with the. Nah?
But I don't have alternate.
Oh, your keyboard don't have the ALT.
No.
Okay, never mind. Okay, never mind. So yeah. Anyway, probably if I look at your keyboard, then I know what keyboard is this? You buy it together with the iPad from Apple Store?
Yeah.
It's the original keyboard with Apple iPad.
Yes.
Okay, good. Then you should have the key alternate. Anyway, when I meet you next week, I'm going to like show you. You can actually key this in. Okay. Okay. Next. This question. Yeah, over here. This one is very simple. You just replace all this, then you should end up with the answer. Okay. So in fact, 304 divided by 9. So is 33.8 the exact answer? Or you round, or you already round it? Did you round this? Or is 33.8? Looks like you have rounded this answer already. Let me
I rounded.
Okay, you round it. Okay, it's 404 divided by 9. Okay, so it's not okay. In fact, you could have done this because can you see? I see the pattern already. It's 7777 all the time. So what you could have done is you could have done 33.7 and then put a dot on top. Okay, so this is one way, and then of course you can actually express it in fraction. I mean proper fraction. So what's this? Okay, I need to use, so it's 327, then this is 34, then 327. You're going to get what? 70, then you're going to have 7. Okay, so it's 709. Okay, so both are accepted. I mean, both answers are acceptable, except this is a round off, so it's not preferred unless the question asks you so. Unless the question says please use that 1 decimal places. If not, you're expected to write in these two, because you have already know what these two are rational numbers. Now you have more. Now the range of numbers you can use are much broader than you used to know. Okay, so with this topic, and then you're supposed to write in the most exact answers. All right. Okay, before we go to the second half of our lesson, which is here, and of course I think you submitted 2 homework. We are going to talk about it in our second half, and then let's have a 5-minute break and we come back. Shall we?
Okay.
Okay, see you in a while. All right, I'm back. Let me know when you're back as well. All right, I was searching about the magic keyboard with iPad. Okay, the alternate key is this one. Can you see the option word here? Okay. Do you have this key? Do you have this key on your keyboard? The option.
Yeah. Yes.
However, you want to try this, and then you just press this option plus just now the comma key. So see if you can send me the smaller equal or bigger equal sign. Did you? Yep, nice. So, okay, in fact, right? Okay, you can stop already. In fact, what you could, okay, so basically how you do, how you use the keyboard is this options key, right? Actually, it gives you the another letter on the same key. So if you look at your key, F, the letter F, you can try it with the letter F and see what you're going to get, like options, letter F. Let me see on my this. Oh, I get this. Okay. So basically options, whatever key. So you're going to get another letter on the key or another symbol on the key. All right. So you can go back and play with this. Okay. You get a lot of other symbols. All right. So okay. Next, let's back to this. Okay. You start this question. So have you learned the concept of one significant figure before?
No.
No. Okay, good. So time to take a look. Let me just few slides of this. Are you at home?
Yes.
Sounds like your home has a visitor, right?
No. She's on the phone.
Okay. All right. So, okay. So your mom is also doing Zoom, I guess. Okay. All right. Okay. So let's talk about what's the difference between one decimal place versus one significant figure. Okay. So one decimal place. I think you have learned one decimal place in primary school already. Have you?
I don't.
Yes, right. One decimal place,
Yeah.
two decimal places. All right. So
Yeah.
let's do for this example 2.893. Okay. So for one decimal place, so what I'm going to do is I need to ask myself, where is my first decimal place? So this is my first, and this is my second. So the question one decimal place. So I'm going to draw a line after the first decimal place. And then the next step is I ask myself whether this second decimal place digit, is it going to round up or round down? Up or down? So in this case, the second decimal place is 9. So 9 is you are supposed to round up, right? So when you round up means you add +1 to 8 here, the first decimal place. So you're going to end up with 2.9. So the answer is 2.9 to 1 decimal place from 2.893. Are you clear? I think you have no problem with this. To 1 decimal place.
Yeah.
Okay. Now let's look at to 1 significant figure. To 2.893. Okay, so to one significant figure, I'm going to use short form at 1SF, one significant figure. So the first job is you need to identify the first significant figure. Okay, so just now we talked about one decimal place. I need to identify the first decimal place and the second decimal place. So if I need to use one significant figure, I need to identify a first significant figure and then of course second significant figure. Does it make sense? Same logic. Okay, one decimal place, look for first and second decimal place. One significant figure, look for first and second significant figure. Does it make sense? Simple, right? But for significant figure, remember, there is a catch. That means for first significant figure, there is a catch. All right. Catch means there is something you need to take note. So must be non-zero. Okay. The first, let me just make it bigger. Yeah, good. So the first significant figure must be non-zero. Okay. So just have to remember this. Okay. So you ask yourself, is this non-zero? Yeah, 2 is non-zero. So it's my first significant figure. So if my first significant figure is here, this will be my second significant figure. So I need to do one significant figure. So I draw a line after my, okay. So the dot, the decimal point is here. So I draw a line right after my first significant figure. I ask myself, do I round up or down? In this case, 8, right? So you are supposed to round up. Okay, 8 is bigger than 5 or equal to 5, right? So it's round up. Round up, that means you add 1 to the first significant figure. So if you add 1, you're going to end up with 3. So now the question is, do you write 3.000 or you write 3? What do you think? To one significant figure, which one is correct?
3.
Correct. Because you just need one, you just need one significant figure. You don't need so many significant figures. So therefore, the answer is 3. If you write 3.000, what this means? So I just, first significant figure must be a non-zero. So 3 is non-zero. This is my first significant. This is my second, and then third, and then fourth. So basically, if you write this answer, basically you are doing to 4 significant figure already. Then you must be asking, hey, the second significant figure is 0. Do you care? You don't care. Second significant figure can be anything. The only catch is you only pay attention to the first significant figure. We must be a non-zero. So far, so good?
Yes.
Okay, good. So what about this? 0.0356 to 2 significant figure. So if you remember, to 2 significant figure, you need to look for the first, the second, and the third. And then of course, the first significant figure must be non-zero. Then I ask myself, is this non-zero? Oh no, it's 0. So this is not my first. Come to this. Is this non-zero? Oh no, it's 0. So this is not my first. In fact, the first start from here for this case. And then this is the second one. And then this is the third one. Okay, what I'm going to do over here, it says to 2 significant figures. So I draw a line. I draw a line after my second. And then I ask myself whether this third is round up or down. So it's round up. So it's +1 to 5 here. So you're going to end up with 0.036. So this is 2 significant figure. So are you clear? Are you clear? Then
yes,
you must be asking, why do we need to learn 2 significant figure, 2 decimal places? Do you have any idea why? I think you know why we need to learn 2 decimal places, right? Because I think you remember it so well because in dollars, okay, okay, we can only express our number to cent, right? So that's why you need to use two decimal places. Because beyond cent, I don't know I don't know how you are going to transact. All right, even these days we are not talking about cent already, because there is no 1 cent in Singapore. Last time it used to have 1 cent, but these days, yeah, we don't talk about cent anymore. But generally, we accept the fact that okay, for money, for amount in dollars, we use two decimal places. All right, so I think you know why we need to learn 2 decimal places. Then why we need to learn about 2 significant figure, or 3 significant figures, or any significant figure? Do you know why? Do you have any idea why?
No.
Okay, so whether it's 2 significant figure or 2 decimal places, okay, all these they are just methods for us to estimate or approximate. Approximate means round, round off, not exact. Okay, estimate, approximate, round off, they mean the same thing. Right, so we just want to estimate. We don't want to know the exact number. Okay, so I was having this lesson with Yixing, and then I asked, what is the number? What's the number of COVID-19 deaths in the world right now? Can you give me a guess? What's the number of COVID deaths in the world right now? Don't check it. Don't Google it. Just give me a number.
Deaths.
Huh?
Death.
Deaths.
Dying.
Yep. Yes. They are dying from COVID-19.
3 million.
Again, 3
million.
Okay, you are estimating 3 million. Okay. By the way, whether it's 3.125 million, you are not interested. Okay, because who cares about 3.125, you know? So you want to have a whole number, right? This is the whole number. Okay, you want to have a whole number, millions. Okay, in fact, the number is, okay, I last checked a few days ago, is 5.12 something million. Okay,
No way.
so it's 5.12 blah 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 million COVID-19 death in the world right now. Okay, so let's talk about this. So let's 512.05009. Let me see. Too many. Yeah. So yeah. So let's take this as it is. Okay. So we are having like 5 million plus COVID-19 deaths right now in the world. Okay. So when you have this number, I want you to be clear. This number is not exact. In a sense, you know, some countries, they are still tabulating. Singapore is still counting. India might not want to tell you the truth. China is too busy with other stuff. Okay. Russia, probably they are underestimating. Okay. So this number is not exact. Okay. So in fact, this number over here is also an estimate. Okay. And because this is an estimate, so if I ask you, what is the number of COVID-19 deaths in the world right now? You're going to tell me 5,120,501. Who is going to remember this number? No one, right? So that's why we want to use estimate of estimates. Okay, estimate of estimate. So the meaning of estimate means you want to even estimate this. You want to round this up or you want to round this down to a whole number. So it's easier for us or for our mind to digest. So if I round this number 5120509, let me see. So I have this number. So I could have used 5.12 million. This is to 2 decimal places. Why? Can you not see? This is my first, this is my second, and then the third is 0, so I round down. So this is 2 decimal places. Okay, if you don't want to remember 5.12, you could have just 5 million. This is to one significant figure. Does it make sense to you now?
Yes.
So whether it's to 2 decimal places or to 2 one significant figure, basically these are methods for us to estimate. Okay, and I think it's easier to estimate using one significant figure. Okay, and it's easier for us to digest because it's a whole number. Okay, so next time if people ask you what's the number of deaths, COVID-19 related deaths in the world right now, you know the number. Okay, it's 5 million to one significant figure. Okay, in fact, you should say 5 million to one significant figure. Okay, when you say 5 million to one significant figure, basically you are telling people, oh, I have rounded these 5 million numbers using one significant figure. Okay, understand? If you never tell people to one significant figure, when you say 5 million, what people can actually interpret from 5 million is 5 million is the exact number. You understand? You understand or not?
Yes.
So that means if next time you're not sure, let's say okay, what is the population? What's the population in China? Do you know? Population.
1.4 billion.
Yeah, 1.4 billion, and you are doing to one decimal place. Okay. So next time, if you want to tell people 1.4 billion is a round off answer, it's an estimate. So you should add on to one decimal place. All right. Okay, that's the reason why you want to use or why you want to learn one decimal place or two significant figures. Because in fact, if you tell people 1.423 blah blah blah, no one is going to care about all the digits behind because they are not so significant, at least for our knowledge. Okay. Yeah, so next time you could have added this to one significant figure or to one decimal places. All right, when you are asked about large numbers. Okay. All right, so okay, so let's see how we can use our one significant figure to do this question. And okay, so to one significant figure, what you do, you need to do one significant figure for all numbers. So 4.65, 1, 2, 3, 4, and then 0.0983 and 12.1. Okay, so to one significant figure, you need to look at the first significant figure, the second significant figure, and you need to remind yourself must be non-zero. Okay, so apply this. Is this non-zero? Yes, first, second, and then after the first, draw a line. So 6, round up. So when you round up, you plus 1. 4 plus 1, 5. So that means this no longer 4.65, it's 5. 1, 2, 3, 4. First, non-zero. This is second. So the second is 2. So 2 is round up or round down? Round down. So you get 1. And by the way, this is 1, 2, 3, 4. This is 1,234. So your answer is, when you round to 1,000. A lot of students, they round 1, 2, 3, 4 to 1, which is wrong. Do you know why it's wrong? Do you know why 1, 2, 3, 4? If you round to one significant figure, it should be 1,000. Do you know why?
Because 1 is the
why not
first.
1? Why equals to 1 is wrong? Because you start with 1, 2, 3, 4, and this number is in thousands. You can basically, if you get 1, right? Basically, you have shrunk this 1,000 number into 1. So you have shrunk it like 1,000 times, which doesn't make sense. When you round, that means when we do round off, when we do approximation, when we do estimation, our estimate should be close. Okay, if we start with thousands, then you should end with thousands, more or less. Okay, it cannot be so far off. All right, so that is estimate. Okay, what I'm trying to say is, if you have 100 and you cannot say, oh, I round to 1. This is not round off. Okay, this is not round off. This is not estimate. You're talking about estimate. How can 100 you estimate to 1? This is not estimate. This is a very big shortfall. This is no longer an estimate. So that's why you have 1, 2, 3, 4, and you round round down, and you get 1 for the first digit, and then you need to replace by 0, so that the answer is 1,000. And then therefore this is no longer 1, 2, 3, 4, it's 1,000. And let's do the next one, which is this. The first is non-zero, so this is 0, so not first. This is 0, not first, so my first start from here. And then the second is 8, and then I ask myself, 8 is round up, so I need to add 1 to 9, and therefore 9 plus 1 is, you need to go one step in front, so you should end up with 0.1. So instead of this, you get 0.1. And then of course for 12, if you round, so round down, this is first, this is second, you round down, so you end up with 10. Okay, so this is much easier. So the answer is actually 5,000 divided by 1. So the answer is 5,000. Can you use your calculator to help me check what's the answer for the original answer? So I use one significant figure, my answer is 5,000. But what is the original answer? Can you use your calculator? Help me out. And let's see if it's close. So just key this into your calculator and see what answer you get. So what answer do you get?
For the 4,800, 200.
Okay, 48 something.
I mean, and 24.
Yep, sure. So it's
0.04.
4823. Yeah, just let it. So if you do the estimate of this, right, you get 5,000. So compare to do it using your calculator. Okay, I think you can only use your calculator to get this 48 something, because it doesn't make sense if you use you don't use calculator and you use your manual way to do it. It doesn't make sense. So if you use the one significant figure, you could have gotten the answer much faster. Of course, then after that, you need to say to one significant figure, just to let people know 5,000 is not the exact one. Okay, you have used the one significant figure to figure this out. So it's a fast way for us to do an estimate. Okay, so yeah, that's how you can actually quickly estimate the value for this. using one scientific figure. Now, of course, the second question over here, it says using two decimal places. So in fact, to two decimal places, yeah, so you just need to do two decimal places for all this. And then after that, then you use your calculator to help you out. Okay, I'm not going to demonstrate to you because to two decimal places, I think you have learned this in primary school, to two decimal places. In fact, you have not learned one scientific figure. All right. Is that all? Yep, that's all for this one. So let me go to your, I'm not sharing. Let me go to your first one. Do you have other questions for me?
No.
No, okay. Let me go to your first homework. Today is Tuesday, which is intro. Okay. JX intro. Did you do homework 3? Oh no, you do JX prime factorization, right? Okay, good. Let me share my screen. Okay. Yeah, I think you can see your work already. All right. Yeah, pretty good. So the first few prime numbers are this. Okay, so just list them down so it will help in all the questions below. So you also write this as a product of prime factors. In fact, they could have say prime factorization. Okay, so basically what they want you to do is you do prime factorization for 140. So of course you put 2, okay, good. Oh, by the way, 1 is not a prime number, so that's why you don't continue from here. You stop at 7. So remember, stop at prime numbers. Okay, so 1 is not a prime number. I think you know why, right? 1 is not a prime number because for prime number, it must have 2 factors. And then 1 only have 1 factor. So it's not a prime number. So that's why you just stop at here. Stop at prime numbers. So then you pick, so you have 2, 2, which is good, 1, 5, which is good, 1, 7. So if you are asked to represent in prime factorization, this is the answer. Okay, very good. But please take note, 1 is not a prime number, so you just stop at prime number. Okay, this is also a very common mistake among students. Very easy to get 2 marks. So over here, then of course, dun. Okay, good. Okay, good. Okay, good. 3, then 15. Okay, good. Stop at prime numbers. So how many 2 you have? You have. In fact, you can just sum it up quickly instead of going through this when you are more familiar. All right. So you can speed up a lot of your work. All right. Next, product of their prime factor. So yeah, basically these are just some more practice for you. Okay, 2 2s. Okay, very good. More practice. And how many 2? 5 2 1 3. Okay, more practice only. Okay, by the way, when you write this, right, be very careful. So the 5 is the power, should be smaller and on top. Okay, if you somehow just write it like this, I mean, your teacher can mark you wrong. This can be seen as 25 times 3, which is not right. All right, so be careful when you write it. So 2 is the base. Like I say, 2 is the base, and then 5 is the power. So you need to differentiate them very well. All right. Okay, highest common factor. So how do you get highest common factor? So like you say, yeah, you can actually do this. Okay. Or another way to do it is, so just get these 2 out. So for HCF or LCM, I have 2 tips for each of them. So for this it must be shared, and then it must be the lowest power. And then since this is lowest power, So this has to be highest power for LCM. And then for these all primes, okay, so I write down these two tips for each of them. So I just pick. So if I look at this, you have 2 square, 3, 5. Shed is 2 and 3. So I write down 2 and 3. And then after that, lowest power. The lowest power for this is 2. The lowest power for 3 is 1. So this is the answer. Yeah, 12. Okay. So for LCM, LCM is all prime. So I see 2, I see 3, I see 5. So I just write down 2, 3, 5. Right. And then highest power. So the highest power for 2 is 5. So this is the answer. How come your answer is 4? Oh, how come once you write 480 here? How come when it comes to here is 4? Something is missing. Any idea why? Or it's not capture?
Maybe.
Cannot be. When you use your Apple Pencil, if you write 480 and you write 480 here, then when you save, then you should save everything, by the way. Oh. But anyway, this is the way to do it. Just make use of the two tips for HCF and LCM. Okay. Okay, expression 120. Okay, pretty simple. So you just do this. Very simple. So for this, very simple, is they are for LCM. LCM is what? All present. So 2, 2, 3, 5 is present. Choose the highest power for the primes. So 2 is the highest for 2. So 1 is for 3. So 2 is for 5. So you just, yeah, correct. Very simple. This is another practice. So for HCF, very simple. Yeah, just do this. Work out the highest common factor. Just do this. This one, it should be 8, right? How can it be 12? Huh? Right? 2 to the power of 3 is 8, not 12. Okay, so 12 is wrong. Okay, work out the lowest common multiple. So okay, what I want you to see is, in fact, the best way to do is still prime factorization, these two first, and then just make use of the prime factorization, and then just make use of the two tips for each of for the HCF and LCM, which I have given you. So you could have gotten the answer pretty fast if you make use of these two tips after the prime factorization. Okay, so very, very simple stuff. So if I look at this, if this is correct, so LCM means I see these two primes and then choose the highest. Yeah, correct. Of course, when it comes to here, you can make use of use the calculator. Oh, I know why already. I think I think there are a few options for you to choose. I think you need to choose the ink instead of the pencil. Because if you use the pencil, right, then probably your answer is a bit blurred. Okay, I think you can use the ink option, plus you can use the more thick one. All right, so then you won't encounter the missing number or the unclear answer next time. Okay, highest common, yeah, over here. Yeah, for the lowest common multiple, like I say, I just need to look at all this. So I see 2, I see 3, I see 5. And then I choose the highest power among them. Very good. Very simple. Yeah. Very simple. Good. Okay, so in fact, I don't want to basically they are all practice of the same things. All right. So let me see there are any interesting questions. Looks like B is an interesting question. Okay. What do you think? Okay, your answer is 9 and 15. Okay. In fact, when you go to Sec 1 or secondary school, I want you to know that there are more than could be, right? Could be thinking means there are few possibilities. That means there is no fixed answers already. Okay, so when you move on to Sec 1, right, or secondary school onwards, then you will see that, oh, there are a few possibilities, right? No fixed answers. Okay, the highest common factor of my two numbers is 3. So for HCF, like I say, must be shared, right? So that means if this is my first, this is my second one, so my first should have 3 and this one has 3. For HCF must be shared and then lowest power. So both have 3. For lowest common multiple, my two numbers is 45. So 45, you could have split to what? 3, 15, 3, and 5. So 3 squared and 5. It says the lowest common multiple is 3 squared 5. So what this means is 3 and 5 are there. So you could have put a 5 here, or you could have put the 5 for the second one. All right. So 3 must have the highest power, right? So you could have put the 3 here, or you could have put the 3 here. So there are a few possibilities. So you have chosen this. You have chosen 15 and 9, okay? But you could have chosen 45 and 3, okay? Of course, there are other possibilities as well. All right? Does it make sense to you?
Yes.
Okay, so I'm just letting you know, instead of just a fixed answer, in fact, you could have gotten this. Okay, it really depends how you allocate. Okay, how you allocate the power accordingly. All right. Okay, so from your this work, right, I kind of understand that you have understood. If we look at our syllabus, secondary school syllabus. Okay, so you have understood this one very well, and then this one very well, this one also very well. Done, 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 done. And probably this is something I want to talk about, the square root and then the cube root stuff. All right, I think we talked about this question last week, and let me show you the question. I've forgotten where it is. Never mind, let me take a look at this. Not here. Okay, good. So let's use this as an example. So you have 84 times 180. Okay. Divide by k so that it can be square root. So what is the smallest k? So this is a very popular exam questions. Can you work this out? Can you work this out? So I'm going to give you a white canvas so you can work this out. Yeah. Yes. You just worked out. You just worked it out here. Yeah. Or maybe again, make it smaller. Yeah. Yeah. Just work it out over here. The blank space. So what is the smallest integer k? Yeah. I need to be more specific. Integer k. You can do it on this one. Yeah, just on the screen. Yeah. You still remember the steps? You still remember the steps, my dear student? Are you working on it already?
Yes.
Okay, but you're not doing it on the screen, huh? You are doing it on your own. Pardon?
Nothing.
Where are you doing it?
Paper.
Oh, okay, fine. So you still prefer paper? Okay, I'm fine with that. Yeah.
Three, 2, 4, 0, 0.
Huh? No, the K. What's the smallest K such that it can be square rooted? Okay. Can you okay, never mind. So
Wait.
no, okay, the question is, what is the smallest integer K, which is here, such that this whole thing can be square rooted? Square rooted means if square root over 4 is equal to 2. Okay, this is can be square rooted. This is called can be.
236.
Or what I'm trying to say is your square root something inside is a rational number.
236.
K is 236. Oh, okay. Let's look at it.
Yes.
Oh, never mind. I don't know. Let's look at it together.
Oh, no.
Oh, okay.
Wait. 1.01.
1 point. Integer. Integer means no decimal number.
Then I don't know.
Oh, okay, good. So probably you have forgotten. Okay. Regardless, so what you need to do, you need to do the prime factorization for 84 and then 180. Do you have the prime factorization for 84? Have you done the prime factorization?
Two.
Okay, never mind. So let me just. So in fact, to do this question, you need to do prime factorization. All right, but never mind. Let me just guide you. So you have 42, and 2, you have 21, and then 3, 7. 7 is a prime number. Stop. So it's 2 to the power of 2 times 3 times 7. Yep. Let me just erase it first. Okay, I get 84 already. And then I'm going to do it for 180. So 2, 90, 2, 45, then 3, 15, 3, 5. Okay, so I have 2, 2, 3, 2, 1, 5. Okay, good. Okay, so remember, this is a very, very popular exam questions. All right, so what you are going to do is, you're going to replace your 84, which is here, 84. You're going to replace it with the prime factorization. So it's 2 squared times 3 times 7. And then you're going to replace your 180, so it's times, so replace your 180 with the prime factorization as well. So you just, in fact, I have transformed the question. I've transformed the question, which is this. I've transformed the question into this one. Okay. What I have done, I have just used the prime factorization of 84, which is here. I also use the prime factorization of 180. Basically, that's what I have done so far. Okay. So you need to do this step first. That's your step one. After this step, then things are pretty easy. I'm going to show you why it's pretty easy from here onwards. I'm going to crop this out and do it on PowerPoint because I have more space here. All right, good. Okay, so step one, I transform the question into prime factorization. Now, the next step is you are going to combine. So you have 2, 2 here. You have 2, 2 here. So you combine, you end up with 4 2s. So 2, 2 gone. You have 1, 3 here. You have 2, 3 here. So you combine, you have 3, 3. Gone. You have 1, 5. And then you have 1, 7. Good. That's your second step. Now, the question you ask yourself is, can square root 2 to the power of 4 or not? Is this going to give you a rational number? The answer is yes. If you square root 2 to the power of 4, which is square root 16, you're going to get 4. So that means this can be square rooted, so you don't need to divide this. So this can be square rooted, so no need to do anything. Okay, no need to do anything. Now, you ask yourself, can you square root 3 to the power of 3? The answer is no. You cannot square root 27 because if you square root 27, you are going to get irrational number. Okay, so you can't square root this. So if you can't square root 27, what you need to do, you divide by a 3. So if you divide by a 3, you will get 9 inside. You will get 9 inside. So if you get 9 inside, then you will get 3. Square root 9 is 3. Then you will get a rational number. So therefore, the k should contain a 3. Because you are going to divide by a 3, right? So that you can square root 3 to the power of 3. So that's why you need a 3 in k. So do you understand this step? Do you understand or not? Hello, are you still there?
Yes.
Do you understand this step? Why I say k must contain 1, 3?
Yes.
Because your 3 to the power of 3, you can't square root 3 to the power of 3. But if you divide by a 3, you can square root it. So you include a 3 in k. Then of course, now you see that, can you square root 5? You cannot square root 5. Because square root 5, you get an irrational number. So once again, you don't want to get irrational number, so you get rid of a 5. So therefore, the k should contain a 5. All right. Now, can you square root 7? Answer, no, you cannot square root 7 because you are going to get irrational number. You don't want to get an irrational number, so you get rid of 7. So you need to contain a 7. So therefore, your answer is, your k is 3 times 5 times 7, which is 105. So the smallest k is 105. Does it make sense to you now?
Yes.
Okay. So what you need to do is you just need to ask yourself whether you can square root the 2 to the power of 4, whether you can square root 3 to the power of 3, 5, and 7. If you can't, you need to divide something. Okay, you need to divide something so that you can you can square root it. All right. So you just need to test each prime factors and then decide for yourself. By the way, do you need to times 1? No. No need. Because 1 is not a prime number. No need. Okay, so 3 times 5 times 7 is 105. That's why k, the smallest integer k is 105. So what if this question changed to, instead of square root, it changed to cube root? How the answer will change? So cube root. Very simple. Do for each. Can you cube root this? The answer is no. Cube root and cube, they are, so basically you need to remember square root is opposite to square. So therefore cube root is opposite to cube. This is not cube, this is to the power of 4. So you need to divide by 2. So therefore your k should have a 2. So that you can cube root this. So you get 2. Okay, so you need to have a 2 below. So you have done for the first term. You have done for the first term. Second term, can you cube root 3 to the power of 3? Yes. Okay, you can. So don't touch it. You don't need to add anything. So this one, don't need to touch. Can you do for 5? Can you cube root 5? The answer is no. So you need to get rid of 5. So cube root 1, you get 1. Okay, good. So you need to divide by 5. So you should contain a 5. Can you cube root 7? You cannot. So you need to get rid of 7. So if the question is can be cube rooted, the smallest k will be this. So the answer is 70. Okay? Cannot.
Can.
So this is a very common question in your exams later on. All right, so with this, then we can conclude our lesson today. And the next homework will be homework 3, and of course your, let me see, is it homework 3? Yes, it's homework 3. And then if you have more time, you go to homework 4 intro. Okay, you are dealing with ratio and so the next lesson, proportion. The next lesson we are going to do is according to the syllabus, we will start this one, ratio and proportion. Okay, just to share with you, if you don't know, you have N5, N6, N7, G1, so it's 8, this is 7, so this is 8, this is 9, and the last chapter is 10. So you are going to study 10 chapters for set 1. So set 1, you're going to have 10 chapters. And we have completed chapter 1 already. This is set 2 already, okay? So we have completed the first chapter. We have 9 more to go. All right. Do you have other questions from your school or in your life or something to do with your iPad and all those? Any other question?
No.
Have you figured out how to split screen for your iPad?
No.
Oh, still not yet. Oh, okay. So I see you. I will meet you face to face in our next lesson. So then I will probably teach you a few tricks how you can actually be more productive with your iPad. All right. Okay. So hope to see you. Thank you so much, and see you face to face. Bye bye.
Bye bye. So next week is Monday.
Next week, yeah, back to the normal time.
Okay.
Yeah. Thank you. Bye bye.
Bye bye.